Hey everyone, and welcome back to the channel. I am so excited to do this video today. As some of you know, this is a video that I set up as a subscriber challenge a while ago when I hit 600 subscribers on YouTube. And we hit that goal, and thank you so much for that. But then life happened, and I didn't get this video out as soon as I wanted, and now we are at over 800 subscribers on the channel, and that's just amazing to me. I'm so glad that I can help hundreds of you, that you are learning something from these videos, whether you're finding them over on Twitch or you're only watching them over here on YouTube. It really means a lot, and I'm glad I could help you in your journey to learn Android development. Um, so in this video today, we're going to talk about a topic that is really important to me, that I find very fascinating, but I don't put in my content a lot because when it comes to architecture patterns, these conversations are very opinionated. And I try not to let my opinion bleed into everything I do, but I think this is a topic a lot of people are interested in learning about. There are two really popular architecture patterns out there right now in the Android world, and everyone always wants to know, well, which one should I use? And every senior developer out there has to say the words, "it depends." And of course, that's the right answer, but it's not always the most helpful answer. Because it depends on what, right? We need to know what sort of things this answer depends on so that we can make the decision that's best for our teams. And I'm hoping I can show you that in this video today. So what I did for this video is I built a little application that has two screens in it. And I built the same application once with the MVVM architecture, model view, view model, and once with the MVI, model view intent architecture. And what we're going to do is we're going to look at like an architecture diagram for that app with each pattern and try to understand why for a certain screen, one might be better, and for a different screen, another pattern might be better. And at the end of this, again, it is very opinionated. So even if I'm going to try to convince you that for a certain use case, MVI is a better architecture pattern, you don't have to agree with that. If model view view model is something that you like and are comfortable with, you should stick with it. Because I think that's what really matters most, that you know what you're doing, you can understand it, and it's helpful to you. But it's still good to know what all of your options are, and so I'm hoping this video can help you do that. So let's dive in. Let's start by showing you the application that I built for this, and then we'll go into the architecture pattern, or the architecture diagram, and maybe we'll look at code a little bit, but I think I'm going to try to keep this on the pattern itself and how all of the pieces connect to each other. But there is a sample app. This will be live on GitHub. You'll find the link in the description. One other thing you'll find in the description. So I've done a couple live streams before on these architecture patterns individually. So this is not going to be a super deep dive into one pattern or the other. I'll walk you through each one if you've never seen it before. But if you want to understand one or the other a little more in depth, check out the links in the description to learn more about those. But let's look at the app. So I made an app that lets the user keep track of preferences. And they're kind of silly. I just thought of like some Android related preferences. So if we look at like our read preferences screen, we've got like, I wanted to include preferences that are all different types to help kind of sell this idea. Um, if all the preferences were the same type, then maybe we could simplify some code, but I really wanted to show like every preference is a little different. So we've got a switch preference, which is like whether or not the user prefers dark theme. This is the read-only screen, which is why that didn't toggle. We could have like the user's favorite device line, and then how much they love Android. This one should never move. It should always be 10. Right, and we have otherwise an update preferences where these components are actually modifiable. Um, and what we're going to do is we're going to look at an architecture pattern for each of these screens and then show how like they might differ between each other. So I've already written the diagrams for the read-only screens, and I think that's really good because the TLDR of this next section is I think if you're writing a screen that only reads data and displays it, a model view view model architecture is good enough. If you have a screen that has a lot of moving parts, you might want something a little more complex, like MVI, to get better state management. So let's look at the diagrams. Here is like an architecture pattern, architecture diagram of like a model view model architecture. What those words all mean is that it stands for the three components that you have in the application. You have your model, which is usually referred to as like your data layer, which in this case, you can consider these components. So like preferences repository, where you get the user's preferences or update the user's preferences. That's your model layer. Analytics tracker, not necessarily a model, I don't know what to call it, but similar idea in that both of these are referenced by your view model. And what your view model is responsible for is getting the data necessary from the model layer and then converting that into some view state that defines how your UI is supposed to be rendered. And then your view, which is like your fragment or activity, all that's responsible for is taking that view state and rendering it. So if we were to talk more about code, this would be like a live data or a state flow, whatever you like, that would be exposed by the view model and the fragment observes it. We can look at code later, but I really wanted to kind of just focus on like the different classes that are necessary for an application like this and how they all connect with each other. And I wish I was kind of doing this live on Twitch because I hope this makes sense, but do let me know in the comments if anything in this video is unclear, and I'm happy to do another recording later and make this a little more thorough. But these are all of the pieces. So let's talk about a read preference screen and how it goes through this diagram. So when our fragment is created, we are also effectively going to create the view model and subscribe to that view state. And what's going to happen is when the view model is created, it's going to make a request for the preferences, and it's going to update our analytics tracker and say, hey, we viewed this page. And then once this is done, it will update a view state, and that will get emitted back to the fragment. And that's it. And so in this case, this flow of data is pretty clear. This would have a little more state management and that it needs to show a loading screen and an error screen, but it's really just got those three cases: loading, content error, and tracking a page view, maybe tracking if there is an error. And that's fine. That can all live in the view model. That's not a ton of responsibility. Let's look at this same screen with a different architecture pattern, specifically like an MVI architecture pattern. Let's see what that looks like. So this diagram, definitely going to look way more complicated. Let's take it down piece by piece. And along the way, I'm going to explain each box, and then I'll try to explain why this matters. Or let's do this backwards. Let's go back. So all of this is great, but one of the problems to consider is that as our dependencies on the view model scale, this can be handling a lot of business logic. And it's going to have a lot of things going on. State management's going to be harder because of all of these changes. And it's not going to be very clear what's happening. A bunch of stuff's going to go into this view model, and a bunch of stuff's going to come out, and there's a lot of room for error. So let's look at how we could get a little more clear, finite state management with something like MVI. So it starts the same way. We have our view, which is a preference fragment, and it observes some view state that comes out of a preferences view model. But the way this view model is different is that it doesn't interact with any dependencies like a repository or an analytics tracker directly. It only has one dependency, which is our preferences store. A store is a state management container. So this is our source of truth for what our state of the screen is going to be. And it exposes that state for the view model, which will then pass it back to the view effectively. So all of this is kind of like a proxy between the view and our state management container, and what it passes through are things called actions. This could be an action to like fetch data when it's created, which is what happens on our read preferences screen. Or maybe if there's like a button click, it could then convert that to an action and say like submit data, for example. In the store, looks like it has a lot of dependencies, but let's break it down. The most important one is something called the reducer. The reducer is what changes our state. Whenever an action comes into the store, that action is sent off to the reducer with the current state, and then using those two pieces of information, the current state and the action, the reducer spits out a new state, and then that state gets updated and passed all the way back up the line. So, for example, the reducer could take in a current state, which is like loading, and then a new action, like preferences loaded. And then it will output a new state saying, show the data, here are the preferences to show, and things like that. But now we have to ask a question, well, what about things that need to happen that don't directly manipulate the state? And that goes into something called middleware, which is responsible for those sorts of side effect type actions. So every action should also get passed through to all of your middleware. And your middleware only needs to consume the actions it cares about, but it should still be passed through all of them so that it's consistent. And let's look at what would happen here. So if we got like a fetch preferences action, what we could do is we would pass that off to our analytics middleware. And our analytics middleware would be responsible for saying, if we're fetching preferences, that means they viewed this page. So call the analytics tracker and say that we viewed this page. And when it goes into our data middleware, we see fetch preferences action. We see, we actually need to go to the repository and fetch the preferences. And then what can happen is the response will come back from that. I don't really have an arrow for that, but that response comes back, and then the data middleware emits a new action, and then the preferences store says, data has been loaded, that new action goes into the reducer, and everything carries on from there. So this is a lot more pieces, but it is very clear unidirectional data flow, very clear state management, especially when it comes to the reducer. Because this is the only thing manipulating state, it's very clear. Given an input, action, and state, we get something out. And we no longer have this view model that's doing all of the work. But I explained that for a read preferences screen, this is complicated, right? There's a lot going on here for the sole purpose of loading and displaying preferences. But let's talk about where this could actually start to shine a little bit. Let's go back to the app and let's talk about the update preferences. So update preferences has the same steps as before. This loaded really fast, but it is fetching preferences, which have to load and then display them. But it also needs to respond to any changes to our preferences. So let's look at the MVVM diagram, and let's try to draw this out, what these additional things would look like. So let's say every preference is a new network call, right? Well, first, before we even think about networking, we're going to have to add an arrow here that is like, changed dark theme preference. Can you see that? Kind of. Can space these out a little further. But that's one connection. We're going to have another connection. Oh man, sorry. I'm a little new to Miro here. We're going to have another connection, which is like changed device line preference. And then we're going to have another one, which is going to be, our changed, what's our other one? Love for Android preference. And so we've got to add all these connections between the fragment and the view model. But in addition to that, we're going to have to duplicate all of these lines. We need to know when we updated a preference. And I'm just going to put times 3. Imagine that there are now 3 new lines here. And if we want to track analytics whenever the user does something like that, which is valid, that's an interesting shape. But we're going to have to put, track pref updated, which is also 3 new lines here. And just in these boxes, even though it seems very clear, like, this means a lot of responsibility inside our view model. Each time we update a preference, that response is going to come back with a new list of preferences that updates the view model, which updates the view state. And this can quickly become a God class, because we're looking at an app that just fetches preferences from a repository and tracks some analytics. But in a more production case, your view model might have several dependencies. Maybe we're pulling from 2 different types of repositories. Maybe we've got some sort of event bus in our application, an error reporting that's different from analytics, performance monitoring. We track a lot of other things, and all of a sudden this view model has way too many responsibilities. So even though it's simplified in the number of components that are used, we really don't want this to have all of those responsibilities. So let's talk about, what do I want to say here? Well, I really wanted to call out, words. All right, let's go to the next one, and then I think I can explain what I'm about to say. So let's do the same idea of adding all these new lines to our new diagram. And keep in mind the number of connections that have changed. So like I said, we've got 3 preferences. This is 3 new connections to the repository, 3 new connections to the analytics tracker. So let's take our MVI diagram, and let's think about what this would mean if we followed the same sort of setup. Well, the connections between the fragment and the view model would exist. Changed preference. And because they're different UI components, we are still going to have to add like 3 new connections here, 3 new calls to the view model based on which preference was selected. However, each of these could get mapped to like one singular action. And so we can just pass some action from the view model to the store. And this is really just one connection. Even though you can think of it as like different actions are created, that's going to happen inside the view model. There's still only one function call to the store. We would do store.dispatch with an action. And then similarly here, for each call to the middleware, we can just pass the action that we want. And then what will change is here, that this will be the new action. So every time a new action happens, we're going to have to add 3 connections from our analytics middleware to the analytics tracker. And from our data middleware, we're going to have to do the same thing, fetching. So there would be like 3 updates to this. But these updates now are specific to, a little more specific to those components, right? It's very clear this is now a single responsibility. These are the analytics updates with the new preferences. These are the data updates with the new preferences. And they're inside classes that are very specific to those responsibilities. They're not all being chucked inside of this view model. And then our reducer actually, well, inside of here, you can think of this as like a fancy switch case or when statement. That will need to be updated. But this connection right here, all of these individual connections, specifically these lines, our connections to the middleware won't change. We want to pass an action to the middleware. We want to pass an action to the reducer. The only things that need to be updated to this update preference idea is the relevant middleware that are changing based on what we've added to the screen, and the reducer, which is the state management. Um, our view model is effectively unchanged, aside from the new UI components. So, to me, this is a lot nicer. We've now split up responsibilities in a way that makes this much more maintainable as we add more UI components and more, moving parts onto our screen. So I hope this, and I'll talk about this a little more in depth as we keep going, but actually at this point in the video, like, that's the concept. That's what I've been trying to explain, is that in an MVVM architecture, if you were just pulling and displaying data, or maybe even if you have one UI component like a button, this works out pretty well. And in that same case, this feels like a lot of work. But if you have a lot of UI components that each make their own sort of data requests, they each need to be tracked via analytics, they all manipulate state in one way, then setting up a more finite state management system, like an MVI architecture, might work better for you and your team. So that's the gist of it. I think that maybe we can look at some code a little bit. I did put this project up on GitHub. Actually, at the time I'm recording, it's not live. Oh my god, I can't type. Or it's private, but you will see it. And I have everything split up into 3 modules. And let me explain what those 3 modules are so you can... What I wanted for this was to have a video that explained the differences at a high level, but putting an app out there where you can really look at some of the differences yourself. So let me suggest how I would approach this. The core module has shared code between both things. So this has the data layer and the analytics, dummy analytics tracker, all of the UI code. You can look at it if you want to, but it's not really relevant to the architecture. What I would look at is, we talked about how each one had a view model. And so what I would do is, this is our MVI article, MVI one. We can open that update preferences view model. And similarly, in the MVVM package, we also have an update preferences view model. And what you can do is use Android Studio, split and move right. You can put these side by side. And then you can take a little look at what the differences are. So let's walk through some of them inside this view model. So in the MVI side, we reference a store, which is our state management container. And as our app scales, this should not change. We should only ever need to depend on the store. But with the other architecture, we have 2 dependencies in our case, but this could continue to grow with additional dependencies if we needed it to. We still expose a view state. It's a little different in how it's created. In this case, we're referencing it from the store. In the MVVM case, we manage it ourselves. But what we see in the MVI case is, you'll notice each time we do something, we're always just calling store.dispatch. That's all we need to do. So all of our unit tests for the view model can just be to verify that when a certain function is called, the correct action is dispatched. And that makes our tests cleaner, that we're just verifying that this thing went out. When we want to test, like, actually loading data, that's going to happen elsewhere inside that, like, data middleware that we talked about. But the opposite is true in the MVVM thing. If we look at fetch preferences, we now manipulate state to show loading, we fetch preferences, we manipulate our state again to show that we're done, and we have to call our analytics tracker. Writing tests for this is complicated. We've got one function that's doing multiple things here. And then this complexity grows as we have this prefers dark theme changed, and we've got favorite device line changed. Each time it's the same thing. We've got to update our preferences, update the state, and track the analytics. And so I think this side-by-side comparison can be helpful for seeing how the 2 architecture patterns differ. that even though we have a lot more files when we use MVI, the responsibilities are a lot smaller. If you look at the line count here, this responsibility for the view model is almost cut in half. And that's really nice. And our view model is doing one thing. It maintains that single responsibility principle, right? This does not. There are multiple responsibilities happening here. But just for completion, to go back, if we look at like read developer preferences in MVI and then read developer preferences in MVVM, if we look at these side by side, they're not that different. Here we're dispatching, fetch preferences. Here we're updating our state and tracking analytics, which again does break the single responsibility principle, but for a single screen that loads some data, it's not the worst thing in the world. At least that's my opinion. So do check out this project. I'll put it in the description below. But yeah, I think that covers everything. Thank you all for watching this. I hope it was helpful. Let me know if it's not. I'm kind of accepting that this one might not go over well, in which case I could try to clean some things up and clarify this a little better. But I hope this gave you an understanding of why one screen, which has a lot of inputs, will be better with an MVI architecture versus a screen that's just loading content error. Yeah, so I hope you enjoyed it. Thank you all for watching this. I was excited to do this because I've learned part of why I waited so long in this video. I'm breaking the fourth wall here. Is I spent so much time thinking about how I wanted to put this out there. And then I realized I needed to do it the same way that I do my Twitch videos. I need to do it one raw, uncut presentation where it's just kind of following my thoughts from start to finish. I thought that was weird for YouTube, but I've learned, that's how all of my stream videos are, and you all seem to be enjoying those and learning from those. So I hope this is the same way. I hope that even though it wasn't live, that it was conversational and you learned something. And again, do let me know in the comments if you have any questions or if I can clarify any of this. But I hope you learned something, and thanks for watching.